G'day and welcome to the Sea Creatures podcast, a show all about the amazing animals that live beneath the waves. Each episode we chat about a specific sea creature with guests who have spent time and interacted with this ocean animal. Our guests range from marine biologists to divers to underwater photographers, citizen scientists, and people that have an intense passion for marine life. Also, if you've liked the show so far, don't forget to tell a friend and spread the word. My name is Matt Testoni, and joining me for this episode of the Sea Creatures podcast is Simon Branigan, and he's a marine restoration practitioner and works at the Nature Conservancy. And we're going to be talking all about shellfish and shellfish reefs. Simon's been working really hard to restore these critically endangered habitats. Welcome to the show.
Thanks, Matt. Excellent to be on.
So tell us, first off, what is a shellfish reef?
If you audience can picture a coral reef, you've got a three-dimensional structure that comes up from the seabed. They can come in different forms, but rather than coral being the dominant feature of that reef, you have oysters and mussels, and you have a bunch of other flora and fauna species on there as well. But yeah, an oyster or a mussel reef or a shellfish reef is a reef that is dominated by a shellfish species, a three-dimensional habitat that comes up from the seafloor.
Cool. I really like that kind of way of describing it. I've never thought of it like you kind of picture a coral reef, but instead of all the like colorful corals, you've just got mountains of these different shellfish.
Yeah, I guess I've been working in this field for a while, and I would argue that a shellfish reef is just as beautiful as a coral reef. As we know, the temperate seascapes down here is wonderful for diving, and certainly do hope that the shellfish reefs that we're involved in restoring in the bay become a dive place as well. But yeah, there's a remnant reef in Tasmania on the east coast. We've got the water clarity down there is usually quite good, and we've got some beautiful photos of sort of the Austrian-Gazi, the native oyster, and kelp, and sort of other species that are colonizing the reef, scallops, etc. So yeah, definitely want to capture people's imaginations around shellfish reefs.
Yeah, and I think it's so cool because I think they are like there's so many habitats that are just as beautiful as like the Great Barrier Reef. But tell us, so especially where to like your work is in Port Phillip Bay in Melbourne, and so I believe it's oysters and mussels are the main colonizers of these reefs. So tell us a bit about what an oyster and a mussel is and what the differences are.
I guess I'll take a step back. There's a bunch of bivalve species, be it scallops or abalone, oysters or mussels, but it's actually the oysters and mussels that are the reef-forming species. As we know, the scallops grow in great abundance together, so do abalone, but they don't cement together and grow on top of each other and create a reef over time. In Port Phillip Bay, up to 50% of the seafloor was once dominated by oyster reefs and mussel reefs. The traditional owners around Port Phillip Bay should just sustainably harvest these reefs for thousands of years. They're of great spiritual importance as well. When the Europeans first came along, there was an oyster rush. So these oysters were largely sort of decimated by the sort of late 1800s. So yeah, in Port Phillip Bay is the Austrian-Gazi, the native flat oyster, which is the native species, and we have the blue mussels. There still are remnant populations of these bivalves in the bay, but at quite a low population base.
Okay. And so these mussels and these oysters, they kind of disregard their shells when they die, and that kind of is what forms the reef, much like a coral reef kind of forms off other dead coral, I guess. Is that true?
Yeah, that's a good way to put it. So I guess you'll have a mature oyster that will sort of release larvae into the water column. That larvae could actually land back on top of the oyster that released the larvae, or an oyster nearby, a living oyster. So you can actually get sort of a bunch of living oysters sort of cemented together and still sort of living and breathing and filtering the water. But below that, you'll have a substrate of dead oyster shells or mussel shells. In the bay, we do think it was sort of mixed reefs, both oysters and mussels coexisting on reefs, but there would have been circumstances where you just had an oyster reef and just had a mussel reef as well.
Okay, so like I was initially picturing like oysters and mussels living together on top of each other, but is that not the case, or is that the case?
Well, I guess there's not many remnant reefs to look at, unfortunately. 99% of these reefs have been lost. The remnant reef down in Tassie is very much sort of dominated by the Austrian Gazi, the flat oyster. So that's the dominant substrate. For it to be classified as an oyster reef, you need at least 50 mature oysters per square meter. And generally speaking, you'll have sort of 50 to 100 per square meter. But I do think in Port Phillip Bay, there would have been plenty of circumstances where you had both the oysters and mussels sort of living together. Potentially, they have different settlement queues that they complement one another. We've certainly found on our reefs where there are oysters and mussels, they are sort of coexisting quite happily. Not very sort of biological word there, but yeah, you dive down there and they certainly seem to be at home in that new ecosystem that we've created.
Yeah. So tell us, like, so most people will know what an oyster or a mussel is, but tell us a little bit more about what they are and what they do, and that'll kind of lead us on to why they're so important.
So yeah, I guess both species are a type of bivalve. They're incredibly efficient at filtering the water. So I guess part of basically they'll be down on the reef, they'll be open, you can see them feeding. So they're filtering the water column, they're improving the local water clarity. And same as humans, we eat stuff and then we have waste, and they basically release these little packets of fish food. So that's why fish are so attracted to these shellfish reefs, these biodeposits that will either sort of land down in the sediment or sort of float away. And that's what sort of provides the food for the number of different fish species that will colonize these reefs. Most people, when they think of oysters or mussels, they'll think of them on our dinner plate and don't sort of think beyond what the ecosystem role may be. The reefs that we're building is very much for biodiversity and improving the health of Port Phillip Bay and the other estuaries that we work in. So yeah, bivalve species similar to the abalone and scallops, but these are reef forming, which is a little bit different to those ones. But yeah, incredibly efficient at filtering the water and creating habitat for other species and a food source for other species.
Yeah, I always like when people, because people do, you mention oysters or mussels, like, oh, yum. And they're always talking about how to eat them. And after I did a bit of research, like a few years ago on them, I was really like, I don't know if I want to eat an animal that filters all of the dirt and muck that comes out of some of our rivers. As like, and that's its whole job is just filters out, a lot of animal waste and a lot of animal feces and grows. And it's kind of gross when you think about it, I guess.
Yeah, the filter feeders, I guess, to put people at ease in terms of what they buy at the seafood wholesaler or elsewhere, particularly in Port Phillip Bay with the mussel growing by the aquaculture farmers. It is closely regulated by the EPA and others, so they can rest assured that the mussels or the oysters that they buy in the supermarket are fresh and healthy to eat. However, when you do have oysters and mussels in the wild that are growing, maybe in the Yarra or close to sort of outfalls, you want to leave those ones alone.
Yeah. And so I think what is it? They can filter a bathtub of water per oyster per day. Is that right?
Yeah, so yeah, they're incredibly efficient at filtering the water. So if you can imagine thousands, if not millions, of these oysters providing that ecosystem service every day, it's quite incredible. If you built enough reefs in the right locations, it could sort of basically filter the amount of water that is put back into the Port Phillip Bay system, on a regular basis.
Yeah. And I mean, if anyone hasn't seen this kind of the project that we're about to talk about, just first off, there, Port Phillip Bay is a huge area, way bigger than Melbourne is. And it used to be covered in these shellfish reefs. And then they're pretty, as you said, 99% gone. You go, wow, I wonder what that's done to the water quality and the fish population. It must have been an entirely different place.
Yeah, it's really interesting, isn't it? Because we're in a fortunate position where you have Port Phillip Bay, which is 2,000 square kilometres. It's fringed by pretty heavy development on most sections, but it is relatively healthy. We're lucky. We can go diving, we can go swimming. in Port Phillip Bay. There's certainly spikes during summer where you'll have algal blooms, maybe during heavy rainfall events as well. But it's a pretty healthy, functioning bay. But it could be even healthier. You could have even more fish, which is really exciting. So yeah, you look at some of the old photos back in the day, and the Port Phillip Bay was full of sort of sharks and other species, and you'd imagine it would have been quite a different place. But saying that, we are quite fortunate that having this estuarine system fringed by urban development, that it's in pretty good nick already. But we're sort of working to improve it with others.
Yeah, and so part of that work is Shellfish Reefs. Tell us about what you're actually doing. And so you work for the Nature Conservancy, and what the projects entail, because that is super interesting.
Yeah, so the Nature Conservancy has been involved in Shellfish Reef Restoration in Australia since 2015. So we obviously have the project in Port Phillip Bay. We now have established projects in South Australia, Western Australia, and also in Queensland, in Noosa. And next year, we're going to be embarking on a Reef Builder initiative. But yeah, in terms of Port Phillip Bay, I guess one of the key things to highlight in the beginning is that we're undertaking an ecological restoration process here. So this is very different to artificial reefs. We're putting an ecosystem back in the bay that used to be there. Artificial reefs are sort of those reef balls or sort of other concrete structures that are put out in Port Phillip Bay and elsewhere. So the way in which we undergo the restoration process, we follow the standards and principles of the Ecological Society of Ecological Restoration, and it's a reconstruction method in Port Phillip Bay. So essentially, we need to put back the reef substrate, and then because the current population base of oysters and the mussels in the bay are quite low, we need to go back and seed that reef. So a little bit different, say in Chesapeake Bay in the US, where there's been a lot of shellfish reef restoration. All they need to do in a lot of those areas is just put back a reef base, and there's enough oysters in the system that will naturally colonize that reef. Whereas here, we sort of need to do both. In terms of the way we go about the restoration, I guess there's quite a detailed site selection process. So we undertake restoration suitability modeling, and there's a bunch of different parameters that go into that model around bathymetry, some ecological parameters around temperature that the oysters require, for example, proximity to other habitats. So, and that works twofold. So proximity to seagrass, for example, there's an advantage by building a shellfish reef near seagrass, for example, because there's evidence to show that you put shellfish reefs in, it improves the water clarity and quality in the area. Seagrass are flowering plants, so we can get more seagrass coming back. But also, you obviously don't want to build on top of seagrass. So we put a buffer in place to make sure that happens, and that's also part of the permit conditions. Proximity to historical reefs. All the reefs we're building in Port Phillip Bay are at locations where there used to be reefs. Buffers from shipping channels, etc. 2020 is very different to the 1800s. There's a lot of areas in the bay that we can't restore shellfish reefs now because they're a small boating zone, there's a shipping channel, it's an aquaculture zone, etc., etc. So all this information goes into that model. It's weighted with different criteria. Then you come out with a scoring system of areas that are highly suitable down to low. Then we follow that up with sort of baseline dives. The model is only as good as the data that goes into it. And the mapping in Port Phillip Bay is pretty good, but some of the mapping's quite old, particularly around seagrass. So we'll go back, we'll dive that site, we'll commission further surveys if necessary to make sure we choose the right location. And then the next step is to sort of come up with a reef design. So we basically tailor our reef design to suit the conditions. So the way we design the reefs in Geelong are different to the reefs at St Kilda, for example. And the reason being, at St Kilda, it's really a dynamic environment. The strong currents, you have the Yarra plume, you can get waves on the beach, further around sometimes. So you need a sort of a strong structure. So we build our reef bases out of limestone rubble up to about 0.5 metre off the floor. In Geelong, this last construction season, we used a combination of recycled shell and limestone rubble. So a parallel project that we work on is called Chuck Don't Chuck Shell Recycling Project. So we recycle shells from seafood wholesalers and restaurants in Geelong and Melbourne. We cure and quarantine those shells on the Bellarine Peninsula for 6 months as part of the biosecurity protocols, and then we layer a bed of shell around 30 centimeters high. Then we're putting sort of 2 meter clumps of limestone on that shell base. And then whilst all that's happening, at the moment we have around 3 million oysters growing in the Victorian Shellfish Hatchery at Queenscliff. And to confuse things further, we actually settle the oyster larvae on recycled shells as well. So you need, in terms of the life cycle of oysters, the native oyster in Port Phillip Bay is a brooding oyster. So all the action will happen inside the female oyster, whereas the Sydney Rock and Pacific oyster, all the action happens in the water column. Won't go too far down the sex education path, but yeah, all the action happens inside the female oyster, and then it will release the larvae and it will swim around the water column. And after a couple of weeks, that oyster larva needs to land on something to grow, to make it to the next life stage. So we use recycled shells as that settlement substrate, and then we go back and sprinkle seeded culture, we call it, spat, oyster spat on shell, on top of that reef base, I guess like sprinkling icing on a cake, with a contraption we call a bivalve blaster, which is like a reverse vacuum cleaner. And whilst all that's happening, we also have a aquaculture farmer growing out a long line of blue mussels, which were wild set. So this season, we're actually going to see both oysters and mussels on the reefs, whereas previous seasons we've had oyster reefs and then mussel reefs. We've had them separate, but we're going to sort of do both. I guess you could look at it as it's similar to farming. If you have a monoculture, it may be more susceptible to disease, where if you have a diversity of species, it's a lot more resilient. We haven't had any issues with the reefs in terms of disease or anything like that, but I kind of think the more that we can build resilience into these ecosystems, the better.
Yeah, definitely. And I guess especially with like the unknown of climate change and those kind of things, the more species, the more resilient it can be. That's really cool. So one thing I was just thinking about then is, so you've seeded these reefs with a whole bunch of shells and rock. Do you expect them to grow in size, both, I guess upwards is obviously a yes, but outwards as well?
Yeah, it's a really good question. We predict, I mean, the oldest reef in the bay is 3 years old. We sort of predict that it'll take sort of 7 to 8 years for that reef itself to become a self-sustaining sort of ecosystem. We do expect that there will be a little bit of subsidence with that reef base, but that'll stabilize over a year or so. So as part of our monitoring, we do go through and do multi-beam surveys of these reefs to monitor that structural integrity. But after a few years, we do expect that the reef will slowly start to accrete in height. In terms of going outwards, no, we think that they're basically going to grow sort of higher rather than wider, because I guess essentially that the mussel and oyster larvae need something to land on and grow. So we could go back and augment these areas by putting more recycled shell and putting a settlement substrate down there. But yeah, at this stage, but it's not beyond the realms of possibility that you do get some currents and oyster will fall off. It will provide a natural settlement substrate. So it's probably grow in height and it may be a little bit in width over time.
Yeah, and I guess given that the reef, once the reef becomes self-sustaining, and if you did place rock and stuff around the outside, it would be a lot easier to seed that reef, wouldn't it?
Yeah, so I mean, one of the long-term goals is to rebuild the population base of oysters and mussels in the bay. So all we need to do is go out and put out substrate, and these the oysters and mussel larvae will naturally find these reef bases. Yeah, I think nothing's going to change the fact that Port Phillip Bay is substrate limited. So you are going to continue to need to put the substrate down to have that settlement area for the oyster and mussel sort of larvae.
Yeah, and I think that's because I think traditionally when you farmed oysters or when you collected oysters, you could drag up the bottom of the ocean and just destroy it and leave a sandy base, wouldn't you?
Yeah, so back in the 1800s, there were sailboats, and I guess they drag sort of like chain link nets behind the sailboat, and they pull up that substrate, be it oysters was the main target species back then. They'd bag them up, they sold them locally. There was a bunch of oyster bars that opened up in Melbourne, Geelong, and elsewhere. They exported them interstate, and they also bottled them and sent them overseas. And the other way in which the oysters were used, the oyster shells and live oysters were burnt in lime kilns to extract lime to use in building. So a lot of the historic buildings in Melbourne and a lot of the capital cities and elsewhere are on the back of these oyster reefs. So that substrate was sort of knocked over quite quickly. And then you have the 60s to 90s. There was the mussel and scallop dredge fishery in Port Phillip Bay, which would have knocked over that remaining reef structure. So there's still rocky reefs in Port Phillip Bay, but the shellfish reefs are sort of different to that. You will find oysters and mussels on these rocky reefs, but they're not forming that sort of consolidated sort of reef base as such.
Yeah. Okay. So yeah, because I was just kind of interested that it's not like we're making an artificial, as you said. We're just kind of trying to put back the substrate that was once there.
The other key part of an ecological restoration is that basically you have a target. You're looking, what are you trying to achieve? And in ecological restoration, you'll have a reference ecosystem or a reference model. So what I mean by that is that you'll have a natural system in which you are assisting the recovery of this reef, and your target is that this recovery eventually ends up as a natural ecosystem. That goal in many circumstances might be quite lofty in terms of what we've lost, but that's what separates sort of ecological restoration from sort of more sort of the artificial side of things. You're putting back a natural habitat and you have targets of what you're trying to achieve. In Port Phillip Bay, we don't have a reference ecosystem as such. The 9-foot bank is the closest we have to a functioning reef in the bay that we have found out so far. If any listeners know of a shellfish reef, please give me a call or send me an email. But rather than it being a consolidated reef base, it's sort of clumping oysters with ascidians and sort of other species. So we've developed a reference model, and that reference model is based on that reference ecosystem in Tasmania. So you have a set benchmark for the number of oysters per square meters. You have a benchmark around the abundance and diversity of fish species you expect to see after a period of time. You have some benchmarks around the colonization of other sort of flora species. So that's why using recycled shells is really good, because that's putting a natural product back in the bay. And the reason why we use limestone and shells is that they have these materials has a limestone content, which is a strong settlement cue for the oyster and mussel larvae.
And so you mentioned like the settlement. So I read there are a few different ways oysters and mussels will sit depending on the species. But how do the ones locally in Melbourne and Australia, how do they actually attach themselves to these shellfish reefs?
Well, yeah, listen, that's a really good question. So we deploy these reef bases using a barge and a long reach excavator. We aim to deploy the reefs in September, October. The primary reason for that is whilst Port Phillip Bay is recruitment limited, there's not many oysters and mussels left. There still are. So we deploy them at that time of the year to tap in the natural recruitment. The recruitment sort of hotspot for the oysters in the bay is sort of November through to March. And particularly in Geelong, we have had natural recruitment. So if you think of a limestone boulder, maybe 50 centimeters wide, we do get recruitment, particularly on the vertical surfaces. On the horizontal surfaces, that can get covered in turfing algae. Essentially, just the larvae lands, then it turns into oyster spat, and over time it matures into a living, breathing oyster. So they can, when you dive down and have a look at them, they can be flat on the rock, they can be sitting vertically on the rock, they can be at an angle. So there's no real set orientation. When we settle the oyster larvae on the shells in the hatchery, that they actually prefer scallop shells over any other shells, and they'll settle in the cup of the shell. And similarly, you just have, you could have up to 10 little oyster spat. In the beginning, they just look like specks, but they'll slowly fill out. The older they get, the more they look like an oyster over time. So I don't know if that answers your question, but there's no real set format. It kind of varies.
Wow. I just, the thought of a baby oyster is actually sort of cute, I think.
Yeah, I think they're cute, and I dive down and I think they're beautiful, just to open up and then they're feeding and certainly looking happy.
Yeah, and so these reefs, like oysters are very, kind of rough, and as you mentioned, they settle in different patterns, which creates quite a lot of surface area, which is used by a whole host of other animals. What are some of the other animals that you get and you've seen on these shellfish reefs?
At Margaret's Reef in Hobson's Bay, which is not far from where the Spirit of Tasmania goes in at St Kilda. It's sort of further around towards Mornington Peninsula if you're looking directionally. Last time I dived it, the visibility can vary there. And winters, as divers know and snorkelers know, the best visibility is during winter. Last time we dived it, we had around 1,000, a 2-year-old sort of pinky snapper on that reef. So we've had snapper colonising the reef, and it was unprecedented as well. They were staying on this reef sort of, it appears to be year round, and normally snapper will move between different habitats. But I do believe once they get older, they will leave the bay and migrate down towards South Australia. What else we've seen? Sort of seen a lot of weird whiting, sort of pygmy leather jackets. We've been visited by dolphins while we've been down on the reef in Geelong. So yeah, there's a bunch of hula fish. There's another species that we've sort of seen on the reef as well, some flatheads. So there's been a variety of different sort of fish species we've seen over time.
So we're almost at the end now. But do you have any cool facts about oysters, shellfish, or shellfish reefs for us?
I have some cool facts per hectare of reef per year. And when I say a hectare of reef, I guess it's not a hard hectare of shellfish reef. You'll have patch reefs within that hectare. So up to 25% of the seafloor is covered in shellfish reef. So per hectare of reef per year, they can filter 2.7 billion litres of seawater, remove 225 kilograms of nitrogen and phosphate. So really help mitigate those algal blooms that we see during summer, and also help mitigate the nitrogen that is put back in the bay. Provides new home for around 100 marine species, and per hectare we would use around 500 to 1,000 cubic meters of recycled shells to build these reefs, shells that would otherwise end up in landfill.
Wow, cool. And I mean, those facts kind of sum up the whole of the Shellfish Reach project in a way. I was going to have just a little fact about the actual oyster itself, which I didn't know this, but while I was doing the research, they have a 3-chambered heart. I always just thought they were like a, kind of gelatinous blob that filtered water, but I didn't know they had a little heart in there pumping away as well.
And the Australian Gazi oyster can change sex as well. There's a few species that can do that, but that's pretty cool. So if you have a dominance of male oysters, they can sort of change to female. So that's a cool fact. And they're being brooders. That's different to the other oyster species.
And that brooders is where they kind of grow everything inside them and release it. Is that correct?
Yeah, I guess you'll have the male that will release the sperm. Then you'll have the female oyster, which will capture that. Fertilization will happen and then release the larvae. Whereas with, say, Sydney rocks or Pacific oysters, you have the male and female oyster. They sort of release the egg and the sperm, and it all happens in the water column. So that it's a brooding species, which is a little bit different, which makes it a little bit more cryptic. Growing oysters, or shellfish reefs, and growing oysters commercially.
Yeah, I mean, just before we end, that is a crazy thing that they actually capture it, because nearly everything else in the ocean releases and just hopes it kind of intermingles, doesn't it?
Yeah. So it's pretty cool. I love going down the hatchery when they collect the brood stock and they bring them in, and they do their thing over the period of time. So could talk oysters all day. And mussels. Can't forget mussels.
Well, that kind of brings us to the end. But if anyone wants to learn a bit more about shellfish reefs and even oysters and mussels and so forth, and the projects going on, both here and around the rest of Australia, what should they do and where should they go?
So there's a couple of things you can do. You can Google natureaustralia.org.au, or you could Google Reef Builder, which is part of our national initiative to restore shellfish reefs, and that's to bring a critical ecosystem back from the brink of extinction. And we also have a number of volunteer opportunities. We certainly do welcome folk that are keen to volunteer and participate, be it in shell recycling or helping to monitor the reefs on the land. So there's a land component for the monitoring.
Wow, cool. And do you even have a scuba diving component as well, or is that only for the special volunteers?
We need to be, for the Nature Conservancy, we're all sort of scientific divers. So we are, I guess, commercially trained to dive the reefs, but certainly there's another project we have run with the Victorian National Parks Association called Oyster Watch, which is deploying settlement plates throughout the bay to gather data around recruitment hotspots. But yeah, really interested in talking to sort of dive clubs and others around, maybe replicating what VMPA do with the Great Victorian Fish Count. We could actually have divers go down and do sort of periodic sort of fish counts on the reef. It's not happening yet, but sort of open to that. But in terms of the data we collect that goes into our monitoring, evaluation, reporting, that's by Nature Conservancy divers. But moving forward, I certainly see a role in recreational divers in being stewards and monitoring the reefs as well.
Yeah, could end up with the great Australian oyster and mussel count.
That's right.
Oh, well, I'll put any contact details and stuff if anyone does want to volunteer in the notes of the podcast. But that kind of brings us to the end. So thank you again for being on the show.
Pleasure, Matt. Thanks for asking me to coming on.
Sea Creatures podcast is hosted, edited, and produced by myself, Matt Testoni. You can see my photography on Instagram at Matt_Testoni_photography, on my website, www.mtunderwatermedia.com. Production assistance by George McGrath, and music by the talented Dan Musil and his awesome slide guitar. If you've liked the show, jump onto our Patreon account, patreon.com/seacreaturespodcast. Coming up next time on the podcast, we've got Warren from Octonation. And if you know what Octonation is, you can probably guess the podcast is all about octopus. This has been the Sea Creatures podcast. Over and out.